All right, we are going to add and subtract polynomials. You just went through all the vocabulary, so hopefully that's fresh. Um, the process of adding and subtracting polynomials is pretty straightforward. First thing we do is combine like terms. Then we simplify by writing our final answer in standard form. Standard form for a polynomial is the highest degree to the lowest degree for each term. Okay, and we'll talk more about that in a second. Remember that like terms must have the same variable raised to the same power. We'll be adding and subtracting polynomials. We'll also be classifying polynomials. Classifying just means naming them. And as we talked about in the vocabulary, we name them by their highest degree, the degree of the polynomial, so the highest exponent, and the number of terms they have. So for this first example, 6b squared minus 7. We look at the variables and we look at their exponents and we see that this has an exponent of 2. So this would be considered a second degree. Second degree because the highest exponent is a 2. There are also two terms. There are two terms, as we discussed in the vocab, that is going to be called a binomial. So this would be referred to as a second degree binomial. Remember, mono is 1, bi is 2, tri is 3. Okay, let's look at the next one. We have x squared y minus 9x to the fourth y squared plus 3xy. Now we talk about putting them in order from the largest, or determining its degree from the largest exponent. But here we can see there's more than one variable in the same term. So we would add those exponents together. X squared, y to the first, that's 2 plus 1. That would be a degree of 3 for this particular term. This term, 9x to the fourth y squared, we would add the 4 and the 2. This would be 6, a degree of 6 for this term. This would be a degree of 2, 1 plus 1. So we can see that 6 would be the highest. So if we were going to write this in standard form, we would have to do 9x to the fourth y squared, negative 9x to the fourth y squared, plus x squared y to the first, plus 3xy. That term's a degree of 6, that term's a degree of 3, that term's a degree of 2. Standard form is from the highest degree to the lowest degree. And if we were going to name this, it would be called a sixth degree. And there are 3 terms, so it would be a trinomial. Sixth degree trinomial. Let's do this last one. When I look at this one, I have an xy plus 2xy. If you notice, those are like terms. This is really a 1xy plus 2xy. That's going to give me a 3xy. Before we name our polynomials, we always simplify them. So we can't classify them until everything is simplified. So I'd need to add them together before I name it. Now I can see this is a 1 and this is a 1. So this is going to be a second degree monomial. Okay, it's mono because it's only one term because those could be put together. So simplify it first, if anything can be added or subtracted or combined. Then put it in standard form so that the largest degree is first and it goes in descending order. Then name it. Second degree, because of the 2, the 1 plus 1 on the exponents, monomial, one term. All right? All right, let's do a couple more. Here we go. We're going to simplify and classify each of these polynomials. So here we can see we got the addition and subtraction, and we know that our rules for adding and subtracting polynomials are to combine like terms. Combine like terms. So I am looking specifically for like terms. I have an n to the third, and I see no other n to the thirds. So I know that this is going to be in my answer. I have an n squared and I see another n squared. So when I mark my like terms by circling them or boxing them, I'm going to be sure to always include the sign that is in front of that term. The sign in front of the term is attached to that term. It must go with it anywhere that it goes. So if I'm going to combine these, this is going to be like a negative 1n squared plus 5n squared. I combine the coefficients. I do nothing with the exponents and the variable. They stay the same. This would be like 6 dogs, negative 1 cat, 3 monkeys, 5 cats. The n squared we're calling a cat, the n cubed we're calling a dog, the n to the fourth we're calling a monkey. So if I have negative 1, I know that's silly, that doesn't make sense, cat, and I add 5 cats, I still have cats. They don't turn into a different animal. So this becomes a 4n squared. Negative 1 plus 5. I keep the variable and the exponent. Do not do anything with the exponents or the variables. It stays the same. You're just combining them into the same group, putting them together. And I know for my final answer, I must write them in descending order. So right now I have 6n cubed. I have a plus 3n to the fourth plus 4n squared. For standard form, I need the biggest term first. So I'm going to say 3n to the fourth plus 6n cubed plus 4n squared is going to be my final answer. 4, 3, 2, they are in descending order, and I have combined all like terms. Let's do another one. Here I have a's and b's all mixed together, so I need to see if I have any like terms. An a to the fourth, b to the third. I must have another a to the fourth, b to the third in order to combine them. I cannot combine them with anything else except for like terms. So this is a 1a to the fourth, b to the third minus 3a to the fourth, b to the third. That gives me a negative 2a to the fourth, b to the third. Once I use my terms, I'm going to go ahead and put a mark through them to show myself, okay, that's gone and that's gone. Those have been combined. And now what else do we have? An a to the third, b to the fourth, and an a to the fourth, b to the fourth. Those cannot be combined. So I just bring them down into my answer. My next step is to get them into standard form. Standard form is going to be descending order of the exponents. I have a 4 plus 3, that's 7. I have a 3 plus 4, that's 7. And I have a 4 plus 4, that's 8. Okay? These two have the same value, so the exponents add up to 7 on both of them. They don't have the same value the whole term, but they add up to 7. So the 8 is larger, so I'm going to do the 8 first. So negative 4, a to the fourth, b to the fourth. I'm saying 8 degree because 4 plus 4. And then I'm just going to write the rest of the terms. A to the fourth, b to the third, plus 9a to the third, b to the fourth. And this would be my final answer. Degree 8, degree 7, degree 7. Okay? The next one. We have two sets of parentheses with an addition sign between them. The parentheses tell us do anything in there that you can first before you do anything else. Remember PEMDAS, parentheses first. I don't see anything inside this parentheses that can be combined. And I don't see anything inside this parentheses that can be combined. Since there's an addition here, really that's like a positive 1, right? And so you would distribute a positive 1, but distributing a positive 1 does not change any values at all. So I just have 3y squared minus y plus 3 plus 2y squared plus 2y plus 9. Again, I can get rid of the parentheses because they're just grouping symbols. There was nothing inside the parentheses that needed to be done. There was an addition sign in the middle, which doesn't change the value, the sign on any of those. So now I have just addition and subtraction. And again, I'm going to combine only things that are like terms. So I have a 3y squared and a 2y squared. 3 plus 2 is 5. Again, I'm going to make sure I know that, okay, that's taken care of and that's taken care of. All right, I have a negative 1y plus 2. So negative 1 plus 2 is going to give me a positive 1. So I have a positive y. Again, I'm going to say, okay, that's used and that's used. And then I have a 3. Make sure you keep that sign, plus 9. That's going to give me a positive 12. So I end up with 5y squared plus y plus 12. And that is in standard form. Exponent of 2, exponent of 1, no variable at all. 5y squared plus y plus 12 would be my final answer. Let's do one more. Here in example number 4, we have a similar setup to the one we just did, but this time there's a negative sign, a subtraction sign in between them. So first thing I'm going to check, can I combine anything in this set of parentheses? I don't have any like terms. I have an x to the third, an x to the second, and an x to the first. None of those are like. Same situation over here, no like terms. So I'm going to go ahead and distribute out my negative 1. When it's a negative in there, that does have an effect. It changes every sign. So in this first parentheses, I'm just rewriting it without the parentheses. Minus 3x cubed plus 2x squared plus 3x. Negative 1 times each of those. And now I'm going to combine the like terms. I have a 6x cubed minus 3x cubed, so those are the only x cubes. 6 minus 3 is 3, it stays x cubed. I've got a 2x squared plus 2 more x squared, that's going to give me a 4x squared. Again, I want to remind myself, okay, I've used those, what do I have left? Lastly, I have this positive 3x plus 3x, that is 6x. I can see that I'm in standard form, 3, 2, 1. So this is my final answer. So when we add and subtract polynomials, we simply combine like terms. Be very careful with your signs.